Now this is a linear differential equation, right? So when we solve linear differential equations, the first step is always to find the integrating factor. So how do we find the integrating factor? So notice that here the coefficient at y is -2, and the coefficient at y prime is, well, just 1, right? So it means that it is in the correct form to find the integrating factor. So the integrating factor mu of t equals e to the power the antiderivative of the coefficient at y. The coefficient at y is -2 minus 2. Well, the independent variable is t, so I've got to write -2 dt. Okay, so it is e to the power, the antiderivative of -2 is -2t, so it is -2t. So note that when we are doing the factor, we are not going to use plus constant, because we do not need to find all possible integrating factors. So it is enough just to find one integrating factor. So if we add plus c, then we will just kind of find all possible integrating factors for this differential equation, which we don't really need to bother with. Okay, so -2t. So to say that this is an integrating factor, it means that we just need to take our differential equation and multiply everything by e to the -2t. So we have y prime minus 2 y equals t square times e to the 2t. This is the original differential equation. Now we've got to multiply everything by e to the -2t, which is our integrating factor. E to the -2t, e to the -2t, and times e to the -2t. Okay, so here we have some nice cancellations, which is not really important, but well, whatever. Now, the whole point of doing this integrating factor is that now the left-hand side of our differential equation is actually the product of the integrating factor, is the derivative of the product of the integrating factor and y. Maybe, well, just for your information, I did it in the lecture, but maybe I can just do it again, just to make a point, because now if you want to find this derivative, then you've got to do it by the chain rule. So by the chain rule, first we differentiate y, so we keep e to the -2t times y prime, plus we differentiate e to the -2t. The derivative of e to the -2t is e to the -2t times -2 times, yeah, and then times y. And you see that this is exactly the same thing as it was. Now the formula for the integrating factor, it actually comes from this requirement that after multiplying with the integrating factor, the left-hand side becomes the derivative of the product of the unknown function and the integrating factor. This is kind of the whole reason for doing this. All right. Now, so this is t squared. So let me just write it again. So e to the -2t times y, this whole thing prime, equals t squared. Well, we're given that the derivative of some function is e to the -2t times y equals t squared. So it means that this unknown function, e to the -2t times y, is going to be the antiderivative of t squared dt. Well, but then we can solve the integral. This is t cubed over 3 plus some constant. Yeah, and by the way, when we are doing linear differential equations, it doesn't matter if we have an initial condition. It doesn't matter whether we kind of figure out the general solution first and then solve for c, or vice versa, because here it is very simple. Now we've got to just multiply by, well, just to solve for y. So let me solve for y by multiplying this whole thing by e to the times e to the 2t. So e to the 2t times e to the -2t is y equals t cubed over 3 times e to the 2t plus constant times e to the 2t. All right, and now it is quite clear that you know, as t approaches infinity, what's going on. So our solution which is maybe we can take out e to the 2t. So e to the 2t times t cube over 3 plus constant. I think it's quite clear that this whole thing approaches infinity, this whole thing approaches infinity, so y approaches infinity. So the answer is this is the general solution, and as t goes to infinity, all solutions approach infinity.